Okay, I see that we are now live on Facebook as well, so let me go ahead and begin. My name is Daryl Boness, and I'm the Editor-in-Chief of Marine Mammal Science. I'd like to welcome everyone to our March Editors Select Seminar. These seminars are based on papers published in Marine Mammal Science. We will be recording this presentation today, and it will be available on the Society for Marine Mammalogy's website within a couple of days. If you have questions, if you would please put them in the Q&A rather than in the chat, although we will monitor the chat and pick up any stray questions that end up there. So with that, let me introduce our speaker today. Our speaker is Dr. Mathilde Martin. Dr. Martin is a biologist specializing in animal behavior. She's interested in acoustic communication, both of terrestrial and marine mammals. And for marine mammals, she's studied aspects of communication in both humpback whales and Cape fur seals. She received her PhD from the Institute of Neurosciences Paris-Saclay, during which she conducted her studies on Cape fur seals. After completing her PhD, which wasn't that long ago, I believe, she moved to Zurich, where she's now doing postdoctoral work, and she's moved back to terrestrial animals, and will be working on meerkat vocalizations for a couple of years before hopefully she comes back to working on marine mammals. Dr. Martin's presentation today will focus on her PhD, some of her PhD work on geographical variation in Cape fur seal vocalizations during the breeding season, and she'll report on findings from 6 different locations in Namibia and South Africa. Her presentation is based on a paper of hers and colleagues that is now in early view, will be published in the April issue of Science, entitled Geographical Variation in Cape fur seals in-air vocalizations across Southern Africa. With that, I'll turn it over to Mathilde to give us her presentation. Thank you.
Oh, thank you very much, Daryl, for the introduction, and thank you everyone for coming to this presentation. Thanks for the opportunity to present my work today. I'm very happy to tell you about geographical variation in Cape fur seals vocalization. So as you all know, marine mammals make an extensive use of acoustic signal or vocalization to communicate. This vocalization have advantageous physical properties for exchanging information in the types of environment in which marine mammals live. You know that sound waves propagate fast and over long distances. They are reliable in the dark or in low visibility conditions, but the sound wave can also convey a large amount of information, such as cues about an event, like the presence of a predator, or information on the caller's identity or emotional state, and so on. And so marine mammals use acoustic communication for the establishment and the maintenance of all their social interaction in relation to mate attraction, territorial defense, parental care, or group coordination, for example. Some marine mammals also use sound wave for echolocation in order to orientate them or for hunting strategies, but this is not performed by seals, so we won't talk about this today. When talking about acoustic communication in marine mammals, we tend to think immediately to underwater vocalization, such as humpback whale songs on the left here, or underwater calls of a gray seal, for example, here on the right. But some marine mammals, the pinnipeds, do produce in-air vocalizations. And as land-breeding species, they spend a large part of their time out of the water, especially for reproduction. And during that time, they use various vocal signals for mate attraction, territorial defense, or maternal care. I was mentioning that vocal signals have properties allowing them to encode a large amount of information. Indeed, although a species' vocal repertoire tends to remain stable over time in order to kind of keep a common language among individuals, vocalization can still show variation occurring along a gradient. The smallest level of variation we can mention is the intra-individual level. This is slight changes in an individual course, and they are mostly related to differences in its emotional state. This is what we call the dynamic information. Then we can find variation at the inter-individual level. It refers to the static information, which is everything about the color itself, its identity, age, sex, body size, social category, for example. And finally, variation in vocalization can occur between different populations, and this is what we call geographical variation. There are two scales of geographical variation. The microgeographical scale refers to differences in the vocalization between two neighboring populations that have the ability to interbreed or interact one with another. At the contrary, when acoustic variation is found between populations separated by long distances, preventing them from mixing, we talk about macrogeographical scale. Geographical variation has been studied in many marine mammal species with a strong focus in underwater vocalization of mysticets, odontocet, and faucet species. But little is known about potential variation in otorides airborne calls. And this is why today I will present you this study. This study focuses on the Cape fur seal, an emblematic otoride species from Southern Africa. The Cape fur seal is one of the most colonial mammal species in the world, as it forms colonies of up to 210,000 individuals during the breeding season. Breeding colonies are distributed over a wide range of distribution of the species, from southern Angola to the south coast of South Africa. And from mid-November to mid-January each year, we count about 40 colonies in this area, with the biggest represented here on the maps with the blue dots. And this species is a very good model for investigation of geographical variation because its distribution range is quite large, and also because its vocal repertoire is well known in terms of description of the call types, but also how they are produced, the context of production, and their acoustic features. Speaking of vocal repertoire, I will present you the Cape fur seal different call types. Let's start with the females, and the first call type is called the pup attraction call. The female uses to communicate with her pup. It's a harmonic call of a bit more than 1 second. And I will now broadcast you 3 calls coming from 3 different females. Okay, so this is how a pup attraction call sounds like, but females also produce barks and growls during agonistic interaction with other adults. So the bark sounds like this. This is very short call, always produced in a sequence. And the growls, these are 2 different examples of growls. And these 2 call types, they are only used during adult-adult interaction. For males, the most common call is also the bark. They produce the same bark, but they are lower pitch and sometimes a bit longer as well. And they sound like this in males. And males also use growls during their agonistic interaction. And only a few males were reported to produce a call that we name long bark. We don't really know what's the context of production of this call. It is produced before and after a bark sequence. You can see here it's indicated by the red arrows. And it has approximately the same acoustic feature as the barks, but it's just longer. It sounds like this. Okay, so you could hear 2 long bark and 1 bark sequence in between. And finally, in response to their mother, pups produce a female attraction call, which is a bit shorter and higher pitched than the pup attraction call. Again, let's listen to 3 calls coming from 3 individuals. So this is the pup's calls. So the vocal repertoire of this species is quite small. They have like 5 or 6 call types. Let me now have a quick aside and let me show you how a breeding colony looks like and how it sounds like when all these individuals interact together and produce these different call types simultaneously. So this is Cape Cross in Namibia at the peak of the breeding season in December. So this was just to show you how it looks like for the people that are not familiar with seal colony, and especially Cape Fur seal colonies that are huge. Going back to our study, so the goal of this research was to investigate potential geographical variation in Cape Fur seals vocalization at both micro and macro geographical scales. We also intended to compare the characteristics of the study site to try identify the possible drivers that could lead to differences in the species' vocal signals. For this, we selected 6 study sites with 2 breeding colonies in central Namibia, Cape Cross and Pelican Point, 1 on the west coast of South Africa, Lambert's Bay, and 3 sites around Cape Town City, 2 breeding colonies on Duiker and Seal Island, and 1 hauling out site in the harbor of Cape Town. So the study sites were chosen in order to have a range of different characteristics, but they were chosen mostly for their accessibility in terms of getting close to the seals to be able to record them, but also because a lot of breeding colonies in Namibia and South Africa are located in mining areas, so we don't have access to them. Seals vocalization were recorded at each site with a shotgun microphone, either from a boat, it was the case for Duiker and Seal Island, or directly on land for the other sites. Recordings were performed at different locations on each colony and over several recording sessions or days to reduce the risk of recording the same individual twice. For this study, we focused on pup and female attraction calls and barks. And we selected between 1 and 10 calls per individual, only good quality calls. And for each of these calls, we measure a set of 6 acoustic features. So this is a spectrogram of a call, like this is a female call, a pup attraction call. And for each of these calls, we measure the duration, the value of the fundamental frequency, which is the frequency of the first harmonic here at the bottom. We measure also the frequency value of the first 3 peaks of amplitude. We measure the bandwidth, which is the frequency bandwidth within we found minus 12 dB around the first peak. It's a bit technical. There's no point into going into details in this. This is just like very general acoustic features we use to describe a harmonic call, basically. And for barks, we also measure the interbark duration, which is basically an indication of how fast the barks are produced within the sequence. And once again, I won't go into details into these acoustic features, and I also won't go into details in the statistical analysis, but I will explain them when presenting the result. So I will first present you the result of the microgeographical variation investigated between the study sites of South Africa. The study sites are located in a radius of about 100 kilometers. And then we will look at the macrogeographical scale by comparing vocalization recorded in South Africa with those from Namibia. And these 2 sites, like 2 different areas, are separated by more than 1,300 kilometers. And we will incorporate results from a previous study that look at microgeographical variation in Namibia between two sites located 150 kilometers apart. So let's go deep into the result. Let's start with the South African study sites and the females and pup calls. In this table, you have the average values of each acoustic feature measured on the vocalization at each site. Please do not pay attention too much to the values. It's quite difficult to read, but what is interesting here is the result of the linear mixed effect model we perform on each variable to investigate for differences among sites. As you can see, we did not find any difference in the duration or the spectral characteristics of the call here for the South African side, except for the duration for the female attraction call, but this is really minor. And secondly, we used a random forest algorithm to see if this vocalization can be classified into and correctly assigned to their study site of origin based on their acoustic features. So the linear mixed effect model were univariate test, and the random forest is a multivariate acoustic test. It allows to take into account all the acoustic features at the same time. So here I present the confusion matrix resulting from the random forest with the percentage of call correctly classified highlighted in gray. So this shows us the accuracy of the model, so how the model is good to classify the calls based on the acoustic features. And this here, the ACC equal NIR, is basically given by the model, and it means that the accuracy is equal to the no information rate. The no information rate is basically the result you would obtain if the classification was made totally randomly. So here, the accuracy of the model is equal to the no information rate. So it means that the random forest is not good. It doesn't classify the calls according to their study site of origin. So it means here that we have no evidence for a variation in females and pups calls, like significant variation between the study sites at the microgeographical scale. Now looking at barks produced by subadult males, here we did find significant variation in the duration and the spectral features of the calls between the study sites. And the random forest was better at classifying vocalization in the right group. You can see that now the accuracy is better than the no information rate, significantly better, and we have high classification rate here. So here we have variation with barks being longer and lower pitch at Cape Town Harbor compared to Duker Island and Lambert's Bay. Okay. Now let's have a look at the macrogeographical scale and in females and pups calls, because we didn't find any variation among South African sites. We decided to group them together. So now we are just comparing the two sites of Namibia, Cape Cross and Pelican Point, because for this site, we know from a previous study that there are significant differences between the two sites. So these two sites stay separated, and we compare them to the South African site that are grouped together. The analysis is similar to the one before, and this time we can observe quite some differences between sites in the acoustic features of the calls, and a successful classification with the random forest algorithm. And in addition, I'll show you a plot here that is a MDS plot based on the random forest algorithm. And this plot basically scatters the vocalization on a two-dimension space, and we can see that calls from Pelican Point are very different from calls from South Africa, and that, Cape Cross is kind of intermediate or closer to the South African site, depending on if it's females or pup calls. In terms of acoustics, we found that females and pups vocalization were lower in frequency at Pelican Point compared to South Africa, and that Cape Cross was having intermediate values, but most of the time the values were closer to the South Africa compared to Pelican Point. For the subadult male barks at the macro geographical scale, we kept the South African sites separated since we previously found significant variation for them. So here, almost all the acoustic features show significant differences among study sites, with, again, a successful classification by random forest. However, the distinction between sites is a bit unclear. There's a lot of overlap between groups, but in general, what we can see from the table, if you disentangle the result of the linear mixed effect model, is that barks from Pelican Point and Cape Town were longer and lower pitched than the 3 other study sites. So now let's discuss this result. From the literature, we know that there are several factors that can lead to geographical variation in animal skulls. First, geographical isolation and/or genetic drift between isolated populations, differences in body size or morphology of the individuals. We can also find adaptation to environmental effects, such as the habitat propagation properties or the background noise. And this phenomenon is known as the acoustic adaptation hypothesis. And it's also worth mentioning that for some species capable of vocal learning, cultural transmission can play a role in geographical variation of vocal signals, but this is not the case in seals. So in South Africa, we did not find any differences in females and pup calls between the study sites. So how to explain this result? First, the study sites are very close to each other, so less than 1 kilometer apart, like 100, sorry, which allows exchange for individuals among sites and thus invalidates the hypothesis for isolation and genetic drift. Similarly, considering the at-sea movement of Cape Fur seals that was investigated in previous studies, individuals from this site are likely to feed within the same area, and they thus benefits from the same quantity and quality of food, making the body mass hypothesis unlikely to happen here. And in addition, this site have similar environment characteristics. They are rocky islands or peninsula, and they are all highly exposed to wind and waves. So this is basically why we can't find any micro geographical variation here, is that because individuals can exchange between sites, they feed on the same prey stock, and they have similar environment. But unexpectedly, subadult male barks significantly differ among sites in South Africa. However, we just show that the 3 hypotheses cannot be validated, and it's the same for subadult. So in that case, we believe that variation in barks comes from differences in the individuals themselves. And the biggest difference in the barks was found at Cape Town Harbour, where these vocalizations were found to be longer and lower pitch than at other sites. And Cape Town Harbour is actually not a breeding colony, but a hauling out site where almost only male come to a seal-dedicated platform to rest. So we think that these seals might be a bit different from other breeding colonies in terms of age or in terms of behavior. We know that barks' acoustic features can change with the age of the individuals. They get lower pitch when the individual gets older. And the acoustic features also, the duration also change a little bit. So we think that these seals might be different in age, so maybe older in age than the other site in South Africa, and that these barks could be produced in different behavioral contexts than in breeding colonies where the social interaction are more related to reproduction and territory defense. While in the harbor, they are resting, they are mostly fighting for a spot but they are not really doing social interaction related to reproduction or territorial defense. So this is how we explain the differences we find in barks from subadult males in this South African site. And now for the microgeographical variation in Namibia. So it was tested in the previous study. As I told you, the 3 core types were found to differ between Cape Cross and Pelican Point. So here the proximity between the 2 sites also invalidates the genetic drift hypothesis because there's only 150 kilometers between the 2 sites, which is a very small distance for a seal. For potential differences in body mass, we lack of information on where these individuals forage and whether they share the same feeding area or not. So we cannot really conclude about this hypothesis that maybe the body mass is a bit different between Cape Cross and Pelican Point. But the hypothesis, the most likely to explain variation in this vocalization is the environment. Cape Cross colony is located along a rocky coast, exposed to high swell and waves, and exposed to the abiotic noise produced by waves hitting the rocks. At Pelican Point, this is totally different. Seals are gathered on a sandy beach located along a semi-closed lagoon. So the water is very shallow, completely flat. There's no waves and no noise there, except some wind. But because Cape Cross vocalization were reported to be higher pitched than Pelican Point, these differences could be explained by an adaptation to the environment where seal vocalization tend to be easier to exchange when produced with a higher pitch in a noisy environment such as Cape Cross. Of course, this is still a hypothesis and we can't be fully sure about that explanation. It would be interesting to collect more data and have a look at other factors, such as the body mass of individuals, as I was telling you, but also other possible effects, such as the colony density on the acoustic features of seals vocalization. And now for the macro geographical variation scale, so comparing South Africa and Namibia. In this case, the 3 core types were also reported to have significant differences among study sites, with all cores produced in South Africa and Cape Cross being higher pitch than Pelican Point. So that's the main finding. In South Africa and in Cape Cross, they are higher pitched than Pelican Point. And because Cape Cross is further from South Africa than Pelican Point, we can't validate the geographical isolation hypothesis. Because obviously the closer groups are the ones that are the further in reality. So this hypothesis is not validated. For the genetic drift hypothesis, it has been shown that the Cape fur seal actually has a higher degree of genetic diversity within colonies than among colonies, which means that differences between colonies in body mass due to genetic is unlikely. This is due to like the past of this species being harvested for like different several centuries. So it's very unlikely that some colonies would be smaller than others because of genetic differentiation. But we can still exclude an effect of the quantity or quality of food on seals' body mass at this site. Sorry. So we know that it's not, if there is a difference in body mass, it's not due to genetics, but it might be due to the food quantity or quality. And finally, here again, the hypothesis that seems the most relevant to explain our result with the existing data would be the effect of the environment. As I explained to you, Cape Cross is a rocky coast exposed to swell and waves, the same way as the South African site, whereas Pelican Point is very calm and shallow. So the higher spectral features found at Cape Cross and in South Africa would be explained by the same acoustic adaptation hypothesis. And these differences in the living environment of the seals between these different colonies. So that's the hypothesis we could keep at this stage of this study. So as a wrapping up, we found macro-geographical variation that are most likely to be driven by environmental factors, such as micro-geographical variation reported in Namibia, but no difference was found for vocalization coming from study site with similar environment in South Africa. And this study was really a first investigation of geographical variation in that species, but it would be interesting to focus now on different study sites in the future. And also we still lack of information, for example, on colony density, genetics, morphology, breeding site fidelity, or dispersal of the individuals. And this is factor we must take into account when looking at this geographical variation in vocalizations. In addition, further investigation would be needed in the future to assess whether this variation can be perceived and recognized by individuals and how they could influence or modulate the social interaction in the breeding colonies. And this type of study is very important for our general knowledge on how acoustic signals are shaped by social, behavioral or environmental factors in mammals. Thank you very much for listening to me today. I'm now happy to take questions, but if you are interested in reading the article, here are the details, and there is also my email address. If you want to contact me, please feel free. Thank you.
So Mathilde, thank you for that very interesting presentation. A really, really nice design of that project. I like the way you were able to rule out the different potential explanations for what's driving the results you have. One question that comes to mind, since at the moment I don't see any questions from our viewers, but you don't have any data from adult male barks. I wonder if you think adult males and barks might respond differently, if there might be different drivers behind them, given the obvious importance of male barking during the breeding season.
Yes, so that's a very good question. I didn't explain why we didn't include adult male barks. Actually, there's different reasons. The first reason is that the data collection in South Africa took place after the breeding season. So we still had pups and females, but the adult males were gone already. And we had only the subadult males. And the second reason is that in Cape Cross, they are still harvesting the seals. Is it still allowed in this colony? And they are specifically targeting the bulls. So there's not a lot of adult males in this colony anymore, unfortunately. So we are not able to record them in this colony. So the only colony where we do have adult male barks is Pelican Point. So comparisons are very limited, unfortunately. So it would be nice to go back to South Africa and have recording of adult males during the breeding season. Yeah, that would be a very good point.
Thank you. I don't see any other questions popping up yet. So let me ask you one more question then. So clearly in environmental differences appear to be this stronger driver. In this case, do you think if you didn't have big differences between environmental conditions, so if you sort of had that held constant, might you see differences from some of these other potential factors if you didn't have such big differences environmentally?
Sorry, I couldn't get the end of your sentence. So if I didn't get any differences, why? What's the question? Sorry.
Well, so the question is, clearly in all these cases where you have differences, the driver seems to be an environmental driver. And I'm wondering if it's just that So that driver is sufficiently strong that if there were potential lesser effects of some of these other factors, if you had situations where you were having a constant environmental condition, if you might indeed see impacts from some of these other potential drivers.
Okay, I see what you mean. Thank you. I think the colony density might also be a big factor because, as you could hear, the colony is very noisy. Like in Cape Cross, the background noise is very, very high. So I guess this background noise can kind of act like the wave noise, basically. It can be quite difficult for them to exchange information in this. So they might also need to maybe shift a little bit their vocalization to exchange information a little bit more efficiently. So the colony density would be something, and I guess the genetics as well would have a big impact. This is something that is done actually at the moment currently. They are trying to find like genetic differences between colonies, but because of the harvest and things like this, genetic history of the species is a bit complicated. But yeah, I guess maybe with other I don't know, microsatellite or other genetic tools, we could find maybe some accurate response for that. Yeah.
Okay, maybe we have a question, Carissa.
Yes, I'll go ahead and read it out. So Catherine is wondering, could biological factors such as exposure to predation account for some of the differences? Predation effects have been found in vocalizations in some species.
Okay, that's a good question. I'm not sure about that because I mean, at the breeding colony on land, they don't have much predators. They have jackals and sometimes hyena in Namibia, but they mostly go for dead pups and they don't really attack the adults. So I would say the bigger predator of seals are humans in Namibia for the moment. So at least for the in-air vocalization, I'm not sure about the impact of predators, but it might be something to look at for underwater vocalization for sure, because there are big differences in the types of predators they have between Namibia and South Africa.
Great, thank you. I had a follow-up question, which I think you probably covered. I might have missed it. So did you confirm that like a seal that would be all the way up in maybe the northernmost Namibia colony, is that one that would eventually maybe make it to the South Africa one, or are they really site specific? Like how much ranging is there actually going on between these colonies when it would come to sort of sharing calls? And
Okay, so in terms of movement, you mean?
Yes.
We don't have a lot of data on this again, but I mean, traveling 150 kilometers for a seal is nothing, but 1,000 kilometers, it's quite a lot. So I'm not sure the seals from Cape Cross, for example, would be able to go to the south of South Africa. Maybe along his life, maybe if we go south a little bit every year, then it can end up in South Africa, I don't know. But we don't have a lot of information about what's their fidelity to the breeding site and also to their feeding area. There's some evidence that females might not have a very good fidelity to the breeding site, at least where they were born, but maybe they are a bit they have a better fidelity for where they breed every year. But this is still unanswered. I mean, we don't really know. So I would expect them to move in like small areas, but not between countries, I guess.
Great. Yeah, that definitely answers my question, just in terms of how much interchange might be going on if you're finding this similarity otherwise, right? Like,
I'm
what could be
also
some of
not an
the-
expert in seals movement at sea, so if anyone has cues on that, I'm also happy to get information because it's not my field.
Yeah, I was wondering about the implications of if there's less large males at certain sites and what that might mean for females returning to that site year after year, things like that, in terms of breeding or those kinds of implications as well.
Something that is absolutely not published, but we think about is that all the males being harvested in Cape Cross, they might go south and go to Pelican Point before getting harvested, obviously, because there's less and less big bulls in Cape Cross, and there's quite a lot at Pelican Point. It looks like there's a lot more big bulls in Pelican Point than other normal breeding colonies. So there's definitely exchanges between colonies for natural or not natural reason, but yeah.
Okay, I don't see any other questions. So even though it's well before 11, I might just say thank you for interesting presentation. Appreciate your willingness to give the presentation on your paper in Marine Mammal Science. So thank you very much, and hopefully.
Hi, David. Please, before you conclude, I have one last question for Mathilde.
Okay, go ahead, Quentin.
Okay, thank you. So she talked about in-air vocalization. I'm like wondering, do the seals also vocalize in water? And what might be the geographical difference in water vocalizations?
Okay, so there's, again, absolutely no studies on the underwater vocalization in this species, but also in otarides in general. I might have like one or two, but not even sure. It's something that is very unknown at the moment. So we don't really know what call types they produce, in what context, and so on. So I have no idea about geographical variation, considering that I have no idea what they are producing underwater. So yeah, we don't know if they would produce underwater calls for like hunting, if they hunt in a group, or if they do solitary hunting, and then they don't really need to communicate. So I guess we would need more information about in which context and for what reason they would produce calls underwater before thinking about why we could have geographical variation and things like this. But yeah, this is something we definitely need to investigate. But thanks for the question.
Thank you.
Yeah, that makes me bring up a quick follow-up question. So you mentioned that there has been some work with phocids and the underwater vocalizations. Is that right? So is that difference, because I'm not super familiar with the pinniped side of things, is that difference purely like a study question? Like we don't have this information because there just haven't been the studies, or is there possibly that they're like not making those as many sounds and that's part of why there hasn't been as much interest in actually studying, I guess is what I'm asking. Or is it a access question or a tagging availability question? I mean, again, I know this is outside of what you were doing here, but do you have any thoughts on that?
That's a broad question. I don't know why underwater vocalization focused more on phocids than fur seal, actually. Maybe Daryl has a good explanation for that because he's an expert. I don't know, you were about to say something.
Yeah, well, clearly there are phocids that have aquatic mating systems, harbor seals, for example, Weddell seals, walruses. So in those species, you definitely get underwater vocalizations or in-water vocalizations. Interestingly, I think I mentioned to you before your talk that I did some work with colleagues on Juan Fernandez fur seals, and the Juan Fernandez fur seal actually hold both terrestrial and aquatic territories. So I expect you definitely get in-air vocalizations, males that are defending territories in the water, my guess is you probably are getting underwater vocalizations as well. But obviously, you'd have to have, you know, some kind of tag that's recording sound, or hydrophones, I guess, laid out around the breeding area as well. So, you know, but I think it's because there are more fossils that have aquatic mating systems that you see more studies of vocal communication, aquatic vocal communication.
Okay.
Yeah, makes sense. It's amazing, right?
Okay.
Sometimes you feel like there's a bunch of research and everything has been looked into, and then here you go, a whole area that, you know, whether it's because there's not a lot going on, but maybe there is, right? And just hasn't particularly been researched. Might be a whole
Yeah, we
other area.
just have to search for it.
Yeah. Yeah, I mean,
Yeah,
even, you know, the tracking information and stuff like that we don't, you know, have a perfect sense of what that looks like is very interesting.
Yeah, and I don't think we know a whole lot about whether during foraging there may be vocal communication occurring. I mean, then the sort of historical wisdom is that they're solitary foragers, but I think there's more and more evidence that suggests there's some, maybe not cooperative foraging, but foraging in similar location of multiple individuals. So there could be some vocal communication occurring during foraging in some species as well. Okay, well, unless someone pops up here quickly with one more question, I again will thank you for a very interesting presentation.
Yeah, thanks for having me. I look forward to publish again in Marine Mammal Science.
Okay, well, we hope we get you back to working on marine mammals after your postdoc.
Yeah, because meerkats are not the right thing for this topic.
Right. Well, with that, thank you very much, and I guess we'll go ahead and sign off.
Yeah, thank you so much, guys, and enjoy your day.
Thank you, Mathilde. Bye-bye.
Thank
Bye.
you.
Bye-bye, everyone.